Yes, our next speaker, he's currently the Science and Operations Officer at the National Weather Service in League City. And he began his career in the hurricane-prone area of El Paso, Texas. And he became a forecaster with the National Weather Service in Lake Charles before moving to the Galveston, Houston area. He's also had experience as a trade floor meteorologist at Duke Energy and is a graduate of Texas A&M. Okay. I was doing college. His presentation is 2023 hurricane season. Why you need to go, Luann? I mean, what you need to know. So, with no further ado, I'd love to introduce you to Mr. Lance Wood.
Well, thanks, Jimmy. I appreciate it. And it's, I was telling Jimmy before the talk, I think I've talked to about 3 or 4 other different master naturalist groups. So it's kind of good to finally come down here because I haven't met y'all. So happy to be here. I do a lot of this outreach for hurricanes this time of year. Dan Riley does that as well from our office. And howdy for the Aggies out there. Been a while since I graduated, but I do have 2 kids at Texas A&M and 1 that's graduated. So I did my part there for Aggie Nation there. I I always I'd like to start out with this slide just to kind of remind you how lucky we've been here. If you look at 2017, it's a little sobering what's been happening around the Gulf of Mexico there. These are all storms you've heard about. Of course, Harvey, we got the rainfall, but not the wind. And then Laura with a close miss to the east. And then Michael, Ian, and Irma, all Category 4s and 5 hurricanes. And this is only 5 or 6 years here. So it's been kind of spread out over the Gulf, but we've seen very, very active seasons and a lot of landfalls. So if you're wondering why insurance is the way it is and how it's gone up, I mean, some of it's inflation, some of it is just the damage that's actually been happening around the Gulf Coast. So I always like to just kind of start my talk out with the basics, just to make sure everybody's kind of got the idea what the season looks like. Now, we do see some May activity, but in general, we consider the start June 1st. And then for Texas, it pretty much ends kind of mid-October, but the whole season goes into November 30th or so. And there is some December activity in some years. There's about 2% of the activity that's outside June 1st to November 30th. But I really want to draw you, this is a frequency graphic, so don't worry about the numbers too much, just kind of look at the shape of this. But you can really see that we really increase activity in August, September, and then ramp down in October. So August and September is about equally likely for a landfall on the Texas coast, but this is the whole basin, if you look at the whole Atlantic basin. So we really need to be ready in August and September. We can get a June or July storm, but it's way less frequent than what we see in August and September. And the serious hurricanes are usually in August and September because the water is continuing to warm out there. So there's always a little bit of confusion about the Saffir-Simpson hurricane wind scale. So yeah, this is kind of a funny graphic. You hear the meteorologists on TV saying, "Oh, we got a Cat 1 out there, Cat 2." Well, what are they actually talking about? Well, there was a couple of engineers in the 1970s that developed a Saffir-Simpson wind scale, and it was really to kind of simplify what the damage potential is from a hurricane. So what they did is they realized that as you go up a little bit in wind speed, the damage goes up a lot. And that's because the force of the wind is proportional to the square of the wind speed, so it's not linear. So it's a big deal when you go from, say, one category to the next. So if you get, say, a Category 2 hurricane like Ike, where we had winds kind of in that 96 to 110 range, then you consider one same size maybe, but more wind. You go up an order of magnitude in damage from the wind. So $10 million storm versus maybe $100 million storm. And then, yeah, you could be talking billions when you get up to 4 and 5. So it's just, remember, it's just a ranking. It's only the max wind speed. Doesn't really say anything about the size. Doesn't It does correspond to surge to some degree, but there are also other factors. So when it comes to storm surge, we have to model that storm. It's not quite as simple as saying just the category. So just wanted to, and when we say major hurricane, that's category 3 or greater. So if you look around the upper Texas coast, we really haven't had category 3 or higher since 1983. And that's actually what got me interested in meteorology when I was, I believe, 14 years old in 1983. And we had Alicia make landfall and go over Sharpstown, where I was growing up. And I thought that was pretty fascinating learning about hurricanes back then as a teenager. So let's talk a little bit about return periods. But how often do we get hurricanes? Well, if you kind of consider a 50-mile area around Galveston per se, the chance, and it's about the same here if you took Freeport, it's about 1 in 9 chance in any given year of getting a hurricane, close by basically, or a 1 in 25 chance of the major climatology if you just look back many, many years. Now this could be increasing just a little bit if you probably threw in the last few years. This was probably generated a few years ago, but in general it's close to this. Now if you go to other areas like southern Florida, New Orleans area, southeast Louisiana, it's quite a bit higher return periods for and even the Carolinas, which that's kind of who's been seeing the storms if you think about it. But just kind of food for thought. That's kind of our return period on average. If this will advance. There we go. So for Texas storms, a lot of them develop in the Gulf. And so one of the messages today is you may not have all that much time to prepare. I mean, Alicia in 1982 was that way. I remember putting up the plywood with my dad the night before it made landfall. Well, one, we didn't have really good modeling back then, and a hurricane, wasn't forecast as well. But two, it formed south of Louisiana and was only alive about 72 hours, the whole hurricane, the whole storm. And so, but if you take a look at these that have been making landfall since 2010 in Texas, pretty much all of them developed in the Gulf. Harvey had developed before way out there, but then it actually dissipated and in the Gulf. So it's actually a Gulf developer too in some regards. So we really have to be on guard for these storms giving us only 2 or 3 days of notice, period. Like that's all you're going to get once they form. So because of that, we really want people to think about their plans this time of year, and we'll talk about that. If you look at the category 3 or greater, within 60 miles of Galveston since 1900s, not all that many of them, and most of them are a long time ago. So you're going to be familiar, I'm sure, with the 1900 storm, the 1915 storm, both really strong, category 4 type hurricanes. Isaac storm is that 1900 storm that you'll hear about. There's a book written about that. Alicia, which I alluded to. The 32 hurricane was a really bad hurricane, pretty close to home here. And then 41 and 1909 storm. So yeah, it's not all that many, and especially lately, we have not been seeing that in this particular area. We've been seeing it around us, though. So the seasonal forecast, we always show this. I don't know that it means a whole lot for preparedness, but everybody does want to know, like, well, how many storms are we probably going to get? Well, this is a particularly difficult year because there's 2 competing factors for a seasonal forecast. Basically, it's what's going on in the equatorial Pacific. What are the water temperatures there? Because that affects the upper winds in the atmosphere. So right now we have an El Nino developing, and we think it's going to be quite strong. Really warm water in the tropical Pacific. And what that leads to is more thunderstorms over there. And then we get strong winds in the upper atmosphere, basically because of that blow across the Atlantic. So that's a negative for development, especially once we get into September. So the El Nino is kind of ramping up. Usually there's a little lag time in the effect to the atmosphere, but probably by late August, September, October, it's definitely going to be a negative influence on storms because they're going to experience more wind shear. But we're seeing very warm sea surface temperatures, which is a big positive for development. So those are going to compete, and so it's kind of an uncertain forecast. So you kind of figure, well, since you don't know for sure which one's going to be more important, the forecast is basically an average year. The only problem with this is if the El Nino comes on a little bit stronger, gets really strong, then we'll probably have no activity almost towards October. So it's definitely going to have a negative towards the end of the season. Just when exactly does it really enforce it? But I'm a little nervous about the fact that we have these above normal water temperatures because we could get development in the Gulf that's not really impacted by the El Nino driven stronger winds that are primarily kind of displaced to the south over the Caribbean. So those stronger wind shear kind of shut down the longer track storms, but it's not necessarily going to shut down the quick developers. So that's why, this is kind of, there's a lot more than just these numbers if you kind of think about what's going on. So we still have to be on guard for, what might happen close to home here in the Gulf. If you look at the Colorado State University landfall probabilities, now we're looking at all of Texas. So the whole Texas coastline has about a 63% chance this year of getting a named storm, 38% chance of a hurricane, and then this is and then the 50 miles around the Texas coast, 16%. So that's pretty much climatological type numbers for the state coastline. So again, that goes along with the near normal forecast. And they're the only group I know that actually puts out real landfall probabilities. So when we talk about tropical cyclones and hurricanes, just a reminder about, the main hazards are going to be the damaging winds, and that's the flagship hotel there in Galveston after Alicia. Storm surge flooding. Ike was an unfortunate, real extreme example of storm surge flooding there. That's the Bolivar Peninsula, Crystal Beach area. And then I probably don't need to tell you much about Harvey. Harvey, unfortunately, is a poster child for tornadoes and flooding rain. We had a lot of tornadoes. We had a tornado watch for 4 straight days. Kind of hard to even fathom that, but that's what happened because it was such a slow mover. And of course, about the rainfall. We'll talk a little bit more about that, but record rainfall for a tropical cyclone. And we will, of course, have the high surf and rip currents we have to message, and that starts way ahead of the hurricane. There we go. So which are the most dangerous? Well, kind of historically, it's definitely water. And this is why when you evacuate people, it's usually for storm surge. And you can evacuate people for inland rain, but that's usually along a river or a creek or that kind of situation after some of the rain has fallen, because you don't exactly know where the rain's going to fall too much ahead of time. But most of the evacuations are going to be for storm surge. And if you look at fatalities, that's about 50%. And this is probably largely related to Katrina, but we also just saw this with Ian. We had 70 something storm surge deaths with Ian in 2022. So we still have our work cut out for us to get people to understand the storm surge flooding risk. We have a storm surge warning now, which has come about in the last 10 years. We have a storm surge watch. We try to paint the picture of it, but when it comes to shove, people still don't believe what they haven't seen, is my experience. So it can be hard to get people to move to, even this day, out of storm surge threat areas. And we saw that with Ian. And what happens is the believability factor, but they also just reluctant to, and I think the believability factor is kind of just a positivity bias. I've seen that, but it's not going to happen to me. And then by the time they realize it's happening to them, they can't get out. I know they've interviewed a lot of people in southern Florida, and I think it was because of some past storms. They thought, well, we went through Charlie in 2004. It was a category 4, but Charlie was really little, so it didn't generate the surge that was coming with Ian. So there was a misconception there. And then they had the near miss with Irma. So there was a big forecast for Fort Myers for a big surge, but the track shifted and they didn't get it. And so the people that lived there just really didn't believe it was going to be as bad. And then it was originally focused towards Tampa, and the forecast kind of walked back at them. And they kind of anchored, people sometimes anchor, and they need to be outside. I know a lot of people understand that, but some people just aren't thinking. I think they get stressed out and they want to, and in the freeze, they wanted to get warm. So they're even bringing in barbecue grills into their house, not thinking that this could be dangerous. But medical equipment outage is another big one. If you depend on power for medical needs, and that would be a reason to leave as well, before or after. You might be able to stay until the power outage occurs, and then you need to get out of there. And then falls and accidents. You'll see people doing things they've never done before in their life when there's a tree on their house. They decide, I can get up on the roof and cut this tree up, and then there's a fall or an accident. So you just had to be really careful when you're doing something you haven't done in a long time, or you're just, maybe you're stressed out and you're making some bad decisions when you're trying to do things like that. Well, let's just talk a little bit more science about the hurricane. This is Ike. Now notice real quickly how big Ike is. This was why it pushed so much water. And you'll hear people say like, well, Ike was a Category 4 storm surge. Well, it kind of was because it was huge. So it's pushing more water than a small Category 2. So that's why the category is kind of there's a correlation there as the wind speed goes up, but you can't ignore the size of the storm makes a difference. But we have these spiraling rain bands, and those can produce tornadoes, especially in Harvey they did. But the eye wall region is the area that we're most concerned about. That's where the highest winds are going to be. And just to the right of the eye, where that right eye wall comes on shore, that's the biggest surge. So that's the area. And then the surge can extend well out, especially to the east. And Ike was so big, it pushed a lot of water to the coast. So even down here, we had decent surge numbers. I mean, it wasn't necessarily life-threatening down here, but you're going to definitely have had maybe 4 or 5, 6 feet of surge even down here. Because even though you're on the left side, you just had a lot of water coming at you. And you can see a storm of that size does a lot of wind damage too, because it takes a while for the whole wind field to move across you because it's so physically big. Get this one to, there we go. So Harvey, I told you, we missed out on the winds here, but Rockport did not. And this is just a reminder of what Category 4 type wind speed damage looks like. So they had wind speeds kind of in that 130 to 140 mile per hour range in a small area there around the mid-Texas coast, and it was devastating. And there was a lot of damage. There were almost whole structure failures like that with apartments down there near the coast. Fortunately, a lot of things when they're rebuilt are built to better code, but this 140 will push any wind code in Texas because the wind code is only 120 along the immediate coast. And I got news for you. If the roof was put on, 20 years ago, right after the code, it's not going to be rated to 120 anymore. You're probably going to be quite a bit lower than that just from aging. So, you start getting 100+ mile per hour winds, we're going to see damage even with our improved building codes, I think that came in the early 2000s. But so, you're going to be asked to evacuate mainly for the storm surge, but there is some consideration to wind. If we get a Category 4 or 5 type storm forecast here, there's going to be some immediate coastal evacuations, I think, just for the wind speeds. And the inland people have some really tough decisions. That depends on, I think, the trees and the situation to their home and things like that. But I'd just like to remind people that, in that eye wall region, it's going to be rough when you get into these higher category storms. Got to learn to push the button a little bit before I stop talking on the slide. It may not be, just trying to point it to the right. There it goes. Okay. So I won't talk a whole lot about Harvey, but it is the record rainfall for the United States. We actually had been advertising over 60 inches of rain was the record, and that was over there near Nederland. But there's actually some research has been done since, and there's some problems with those gauges there. So I don't think that actually happened. I think the record, my personal opinion, actually occurred in Santa Fe, Texas, and was about 56 inches of rain, just south of our office. But all the official stuff is going to be like 62 inches, I believe, or 65 or 6 over there in Nederland. But like I said, there's some problems with that Jefferson County network on those 2 gauges. But just look at some of the damage that it ended up causing because of all the flooding across a big metro area. It was like $125 billion worth of damage. So it's the second most damaging to Katrina, and we'll see what the numbers end up coming out from Ian. Ian will be right there too, I'm pretty sure, because had flooding and the surge and the catastrophic wind. One of the big things about rainfall, of course, it's the slow movement of the tropical cyclone, not necessarily the intensity. So, Harvey did have a bigger footprint of rainfall, probably because of the intensity and organization compared to, say, an Allison, but they still had really incredible amounts of rainfall. Allison had like 38 inches in Northeast Houston. Imelda, just 4 years ago, had over 40 inches, kind of Chambers to Jefferson County area. We were lucky with Imelda that it set up there and not further into Houston and down here. And then Claudette, some of you are probably going to remember Claudette from '79, really big rainfall producer there. I think over 40 inches of rain in Alvin. So we can get a lot of rain here when they slow down. And it doesn't take a hurricane. Three of those are tropical storms. Um, and Ike, this is just another reminder of how big Ike was. I've got the radar loop on there. Just really the eye itself, physically, at one time probably offshore was like 40, 50 miles across. And that little jog to the right, because Ike was forecast to make landfall down here. I remember that. That little jog to the right saved a lot of people, yeah. If it had gone right over, say, Jamaica Beach, I know the west side of Galveston County on the bay would have had 7 feet more of storm surge. So just a jog around a bay system makes a big difference. And we can't forecast that, more than, say, 12 hours out. So you have to be cognizant of our limitations on some of the storm surge forecasting. A little track change can be a really big difference in storm surge. And this was just a reminder with Ike, you have the 15, 16 foot of storm surge that hit Bolivar, but you have waves on top of that. And then you have this pre-surge, as I call it, or precursor water event. So those big hurricanes that kind of fill up the Gulf will cause a couple of feet of rise just from the basically the winds starting to push water towards the coast before it even gets there. And it was just a gradual rise up to the peak. So Friday morning on Bolivar, people were already stuck. And they thought they were going to have that whole morning to leave on Friday. And then the peak winds didn't come till Friday night. So they were cut off more than 12 hours from the peak winds. And the Coast Guard saved 300 people flying in tropical storm force winds that would have died on Bolivar. That's not really publicized that much, but a lot of people on Bolivar didn't leave. A lot of them stayed to the very last minute, and they wouldn't have gotten out if it wasn't for the Coast Guard flying and picking them up. So don't push it on the timelines on this surge, because it can come up a little faster than you might think there. And that's a picture of Bolivar on the right, Friday morning, way before this main storm surge came. You see that truck there it's already flooded out. And notice the spray on those winds is going back out towards the Gulf. We had offshore flow at that time because the hurricane's still offshore. And the 15 hurricane pretty much had the same kind of storm surge as Ike there along the seawall. Fortunately, they had a seawall in Galveston in 1915. That's just another picture of the inundation. So more than 10 feet of inundation in those red areas. And again, if I could come way further left, even maybe just 30, 40 miles, we would have seen the greater than 10 foot inundation all along Brazoria County if it had come in closer to Freeport. Thank goodness it didn't, and it moved over the bay. So we have some software where we can actually project a storm surge. So you can take, like I said, it's not exactly related to Category 3, but it kind of works because this kind of sums up Category 3 tracks. So this map, and this is kind of hard to see with the light, but this is the levee here. So here's Freeport, here's the levee, here's Lake Jackson. The levee protects, I think, to about 25 feet, at least on this part of the levee. Around the sides, it's probably closer to 15. But the levee probably works with a Category 3 here, unless it was gigantic, and then you might have to worry about the sides and the north side a little bit. But that's the inundation that's forecast with think of it as a really large Category 3 here, because we're summing up different tracks. So this is used as preparedness. So like, if you don't know if the hurricane's going to come here, 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 or here, you just sum up. If it comes here, 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 or here, what does the inundation look like? So it's kind of like a worst case scenario for a Category 3. Probably would work for a smaller 4 as well, since it's not directly tied to the category. But it gives you some idea of what can flood here with a major hurricane. That's why I showed it. And I have a copy of this presentation, but he wants to take a look at it. And so we have really good pre-modeling, and we have real-time modeling where we can put that actual storm in and look at what the storm surge looks like. And we can do that about 3 days ahead as far as the individual storm modeling. If you're 4 or 5 days out, we're going to be looking at stuff like this because we don't know exactly where the track is going to be. Yeah, so that's a good question, because Ike was a 2, but probably more like a 3. So the only thing that's different about this, yeah, so the question there from Jimmy is if I could come further west and put y'all on sort of the right side here, down here for Freeport, I think it would be similar to that. just remember the footprint wouldn't be quite this large on the red. So because these numbers on this particular graphic would be from a storm, maybe making landfall up here. But let's say I came in around Freeport or a little bit left. This whole area would probably been pretty, this would be pretty close for this area. Yeah. Yeah. It would have been a good test of the levee, especially on the sides. Just I know the front of it probably would have held up. I don't know about the sides. You might have had some issues. But so there's a lot of storm surge products out there. For emergency managers, we talk a lot about potential storm surge flooding map. And this is run for the storm that's out there, but it uses the alternate track scenario. So we sum tracks and we give them a 1 in 10 chance, only a 1 in 10 chance of it being worse than what's shown. So it's kind of a realistic worst case scenario. And you can find this on the web. It's called Potential Storm Surge Flooding Map. So if you want to think about a risk product, that's the product you want to look at. The peak storm surge forecast, which is kind of the numbers that are in the Hurricane Center advisory shown on a map. That's more like what is the forecast, like the best forecast we have. Not necessarily a worst case, but what do you think the peak's going to be in an area along the coastline? You would use that. It doesn't say much about the inland extent though, so it has that limitation. And then the storm surge watch or warning, that's issued about 2 days out. The warning's 36 hours out, and it does show inland. We do worry about inland extent on that product, and it's generally greater than 3 feet of inundation. But sometimes, it's not exactly that. It's just kind of a guideline. Like we're expecting a fairly significant storm surge, then we would put that up. Think of it as kind of the potential for life-threatening storm surge is how we want to look at that. But this has been an improvement because during Ike, even Katrina, of course, Sandy, all those storms, we didn't do storm surge watch or warning, and people were kind of underplaying the storm surge threat. So this is an effort to try to highlight these areas better, because a hurricane warning is really just for the wind. The storm surge warning can actually be bigger than the hurricane warning. It might go out east quite a bit further, because there's areas with tropical storm force winds that can see very significant storm surges. They're just not right at the center of the hurricane. So it's kind of nice to have a product just for a storm surge. And I already talked about this, so we won't belabor this too much. But if you look at the whole nation's strongest hurricanes 3 days before landfall, almost all of them were tropical storms. So that's a little concerning, is that the ones that actually make landfall, let's say category 4s and 5s, the strong 4s, they rapidly intensify before they reach the coast. They can't maintain that intensity a long time. So if it's a category 4 or 5 out in the Caribbean, most likely it's probably not going to be a 4 or 5 making landfall in the United States, because it's going to go through some intensity cycling. The eye walls can change, and they just don't usually maintain it super long period of time. So the ones we have to worry about are the ones that we think are going to move over really, really warm water. The conditions are good to become a hurricane, maybe a major hurricane. So all of these that you see, except for one on the left, were tropical storms. Even Ian was that way. Tropical storm, right? It became a hurricane in the northern Caribbean and then rapidly intensified in the Gulf. So that's another reminder that we have to take these storms serious and to look at the forecast. So don't just say, oh, it's a tropical storm out there, I'm not too worried about it. Make sure you're looking at the forecast. Is it forecast to be a major hurricane? Because we've been doing pretty well in the last couple of years on this. Like Ida and Laura, they were all forecast to be category 3, at least category 3 hurricanes, and even Ian. So the problem is people will sometimes not believe that. They're like, well, it's a tropical storm right now. And like I was talking to Jimmy about Rita and how Rita and Katrina are really scary hurricanes, and they were. They were category 5s in the middle of the Gulf, but they couldn't quite maintain that intensity at landfall, so they made landfall as a 3. Still very serious hurricanes, but they're not the nation's strongest at landfall because they peaked a little earlier, is all that happened there. So I want to talk about some things that you can look at going into the season. There's a tropical weather outlook on the National Hurricane Center's website. It's issued 4 times a day. Those are Central Daylight Time. So I usually check the 7 a.m. one every morning because, of course, I'm in the business. And if there's something I'm really concerned about, then I'm checking it at 1 p.m., 7 p.m., and that kind of thing to see how things are changing. Really good product to sort of monitor what's happening. you'll get a location of the disturbances and you get a formation chance for the next 48 hours. And it's color coded. So red is a high chance, sort of orange is a medium chance, and low chance is in yellow. And it's also issued now 7 days. So last year was 5 days. This year they have a 2-day and a 7-day outlook. So you're going to see some larger formation areas this year because it covers a 7-day period. So we're going to be looking at these things a little bit longer. Because of that, these little ellipses are going to stretch pretty far out. So don't get too confused. It's going to look a little scary when you see the red like all the way across the Caribbean there, but it can develop anywhere in there is really what that's saying. So you're going to see some larger genesis areas, especially with fast moving waves and things like that in this 7-day outlook. But it's really just to give you a little bit more of a heads up. So I think in general, it's a good thing as long as you don't get kind of freaked out by all the really long areas of development. And the cone graphic is another, it's a good tool, but it can be misunderstood. So that is the most likely track of the center of the storm, but it doesn't say anything about impacts. And the orange that you see on this graphic is the area of tropical storm force winds. So you can kind of see the size of the storm. But notice the size of that storm, I believe this is Ian, is bigger than the cone in the next days. So if you're using the cone as like an impact area, you got some problems because the cone is just where the center's likely to track. If it tracks on the left or right side of the cone, there's going to be quite a bit of areas getting significant wind outside the cone. And it's based on the past 5 years of error. Just, you know, to 2/3 of these storms track with inside that past 5 years of error. So every year it's recalculated, and every year it's been getting smaller because the forecast error is getting smaller. And that's what this graphic shows you. If you look at, say, the 5-day error, we used to have, you know, errors back in the early 2000s. I don't even think we had a 5-day forecast at some point. That's when we started doing that. It was 500, you know, 400 or 500 miles of error out at 5 days. And now you're looking at, you know, generally less than 300, even 5 days out. But what's really, really important is the 72-hour error. That 3-day error has kind of gone from the upper 200s now to sort of the lower 100s. So we've gotten better, but the problem is, you know, there's still enough significant error when people have to make decisions that you have to make the decision to go sometimes, and you have to realize when you come back, you might have been able to stay at least half the time. That's just the business that we're in. You know, 3 days out when you're making those decisions, you still have a little over 100 miles of error. Now, in a big hurricane, most of them are less than this because it's well modeled. So like you saw some pretty impressive numbers with Ida, even with Laura, forecast track error is really, really low, less than that. But Ian was a reminder that we can still have some tricky ones. And Ian used the whole cone. It tracked on the right edge of the cone. There's also a wind speed probability graphic out there that does factor in the size of the windstorm. So if you want to know the chance of any one particular location getting a wind speed, you can use this. And it's with every advisory issued by the Hurricane Center. Just realize it's a point probability. So it's not integrated like along the whole coast. So the numbers can be a little lower than you think at sometimes, especially for hurricane force winds, because it's the chance at that one point getting hurricane force winds, not like a big area. But it is a good relative risk product. And you can see, again, these are some examples, I believe, from Ian. So you can see it had a big wind field forecast on the tropical storm force side with really high probabilities across a large area. But really useful when you have a storm out there. And it's generated by running 1,000 different alternate scenarios that are basically tied to what happens normally and with historic error for that particular area that storm is in. And then you just calculate the probability. How many of those scenarios are bringing tropical storm or hurricane force winds to a location? So it's just a probability of how many of those 1,000 scenarios are bringing that wind speed. So we are factoring in quite a few alternate scenarios there when those probabilities are generated. And so we like people to look at them. You just have to understand it's a point probability. They can be overlaid with arrival graphics too, so you can see what time are these winds most likely to be there. There's a most likely time of arrival, and then there's an earliest reasonable. So the earliest reasonable is sort of kind of like that storm surge, potential storm surge graphic I showed you. It's only got a 1 in 10 chance of being earlier than that. So if you want to be on the super safe side, You leave before the earliest reasonable. If you want the best forecast, then you use the most likely. So that's kind of how you use these together if we do briefings to emergency managers. Local offices like ours, there, the Houston Galveston office, also have hurricane threat and impact graphics. Kind of try to categorize by threat, how bad is it going to be? So there's an extreme wind threat, a high wind threat, a major wind threat, that kind of thing. Same thing for rainfall, same thing for tornadoes, same thing for storm surge. So you can also generate relative risk from looking at different threats from these hurricane threats and impact graphics. So there's a whole lot of information out there. It's just you kind of have to be introduced to it to know how to use it. So I want to talk just a little bit. These come from NOAA. Just know your risk about water and wind. So in general, and this is kind of an individual thing. That's what I like to talk about. So you need to consider your threats. Where are you exactly? Your house. What is your storm surge risk? How about your flooding risk from inland heavy rainfall? Are you right by a river or a creek? How about strong winds? Can you keep the wind out of your house? Do you have something to cover the windows? Do you have something to brace the garage door so it doesn't blow in? That can be a weak point for garages that are attached to houses. The evacuation zone we'll talk about, but there's just some things you would need to kind of think about your own vulnerabilities, and that's why we talk about people coming up with kind of a family hurricane plan. So what will be used during a hurricane threat for evacuation are these zip zones. So the coastal zone that you see there is kind of that pink color. And then zone A is also zone A, B, and C are coastal zones. So where we are right now would be in zip zone of B, which is kind of a lot of Brazoria County there in the middle. So it's pretty easy to pull the trigger on the coast. It gets a little tougher for zone B and C. Those are tougher decisions. So that's where I think if, zone B, a lot of that can see storm surge risk. C is probably more for the wind. Like we have a category 4 or 5 coming, then we pull the trigger even that far inland just for structure failure and things like that. But B is a tough one. Some of that area has more storm surge risk than others, but they try to kind of simplify it for the public. So if you tie it to the zip code, they don't have to do a lot of thinking about it. But that's how it's going to be communicated for Brazoria, Chambers, Galveston, Harrison, Matagorda counties. And you can get this at the HGAC, I always call it HGAC, but Houston Galveston Area Council.com. Ooh, I went a little fast there. So here we are. So we develop an evacuation plan. So first of all, you got to decide, am I likely to evacuate? What are my vulnerabilities? Even power sometimes causes the need for power in your particular situation may dictate that you should evacuate if you're really dependent on power. But you also want to assemble disaster supplies, food, water, batteries, of course, a charger, radio, cash. You also want to do an insurance checkup, document your possessions in case you had to file a claim and you lost everything. Maybe you take it with you if you're leaving, have that document or have it online where you could get to it. And a communication plan. I can't tell you how many people, I think this was back with Ike, left and didn't tell anybody. And people couldn't get a hold of them and they were like, I don't know, I forgot to tell anybody I was leaving. So just to tell a few people, have some people you need to contact if you're leaving. And of course, if you wanted to strengthen your home, you'd want to do it before the threat. Do you want to have plywood cut for your home? Do you want to, there's even Kevlar material you can put over windows. Now there's a lot of options, shutters, you name it, you could probably do it this day and age. It just depends on how much money you want to spend. That's probably the limiting factor for some people. Plan for your pets is another big one. May want to know a couple of different routes you would take if you're leaving in case there's a problem on one. Be able to get the evacuation order. I think that's going to probably be pretty easy to go. Have a go bag for supplies so you don't have to be digging around at the last second. When you make the decision, you're probably going to want to go pretty quickly. And a lot of people, when they decide to go, they haven't thought through it. And they literally will see neighbors going and just decide, I'll just grab what I can and go. Because they just haven't really thought about it. I know that happened during Ike quite a bit. So when you were talking about your supplies, I think some things to remember are your prescriptions and medicine. Make sure you don't get too low on that during hurricane season. having some cash on hand, you might not be able to get cash. Keep your gas tank. I always keep my gas tank about a half full during hurricane season in case something's developing in the next couple days and surprises me. And then food and water. I think y'all know what that looks like at the grocery store now when there's a threat. It can be really tough to get water in particular. The insurance checkup, consider flood insurance. You know, I have flood insurance. Didn't flood during Harvey, but it was close. So I was kind of glad I had it. I think it's pretty important for a lot of people. I know the cost has gone up, but it's still worth it for a lot of people, unless you really absolutely think you just don't have that risk, which is there's a few cases that may be true. So when a storm actually threatens, you know, that's when you want to protect your home. The pets is a big one. How are you going to take care of your pets if you're going to leave? Things like that. Of course, have your go bag. Help your neighbors. This is a big one. I noticed that a lot of people don't factor in the time it might take to help people that haven't done what they've done. I have to do that with every threat. You know, my phone goes crazy if there's a threat. You know, what do you think? When's it going to be here? What's going to happen? What do I need to take with me? Like, so I know how big this can be. But if you do know people that are going to need help, you know, plan that you might need to help them. Don't have that surprise you. Like my dad, for example, I'm going to have to help my dad make decisions, and he's not going to want to leave, and he probably doesn't have to leave unless it's a category maybe 4 or 5. He's going to have to leave. So I know that, and I'm going to have to, you know, I'm going to have to do that. And then during the storm, just make sure you have a way to get weather alerts, and you know, stay in your safe place. Even though you protected your home, you could still have some issues when the wind comes up or the water comes up. I think that kind of goes without saying. And then after storm, we talked about this. Be very vigilant because there's going to be threats, down power lines, a lot of surprises in the flood zone. Use the generators outdoors, 20 feet from your home, which that's kind of hard to do for a lot of people, but at least be 15 feet, especially if there's no wind. You know, if there's no wind out there and those fumes can kind of build up, you definitely want to be at 20 feet. If there is some wind, you know, it's blowing away from you, you could probably get away a little closer. That kind of thing. So we've already had Arlene, and so with the next storm this year will be Brett. If we did unfortunately go through this list, which I'm hoping not, we don't use the Greek alphabet anymore. We have a new set of names that we use as an overflow. That came out of that 2020 season. And then here's how you connect with the Weather Service, weather.gov/Houston. Hurricanes.gov is the Hurricane Center's website. And we also have on our website, we have a guide for hurricanes and severe weather that you can download if you just go to our website, which again is just weather.gov/Houston. So it's pretty easy to get a lot of what the information that I told you from these sites. So, and that's all I got for y'all. And hopefully if you have any questions, yeah, I can try to answer them, sure.
Okay. Okay, if folks in the room have a question, let me bring the mic to you. I'm behind you first, Ed.
Yeah, very good. Thank you
Thanks.
very much. Can you speak to the issue of the dust and Saharan dust and how that impacts the waves coming off?
Yeah, so
Okay.
we've seen that like the last summer in particular, it shut down kind of late June, July, and into early August. Yeah, that's tied to the conditions that are there in Africa. It can get really dry there. It's not always dry there, but it can. And when it does get dry there, it's typically early in the hurricane season. We get these episodes of dust that come across the whole Atlantic. We'll get it here even. It'll surge that far at times. And it's just, it keeps things cooler out there and stable. And so you don't get many thunderstorms. And so it pretty much shuts down tropical cyclone activity in that main development region, which is kind of tropical into the Caribbean. But yeah, just less sunlight's getting through. It's a drier air mass, so there's not enough moisture for thunderstorms. So in general, unless it gets all the way here, it's a good thing for us to see that those dust episodes because it's going to suppress the tropics. And we could see that again this year. But usually that dust shuts down by mid-August. It's kind of the end of that season. Yeah.
Two questions. One of them, how did the University of Colorado get so prominent in hurricane investigation?
Yeah, I've gotten
number
that question
one?
before.
And that's been going on for years. And the other one that I'm wondering about is why are the European model much more accurate than the rest of them? You think
Yeah.
the most accurate models on the planet would be here in the US?
Yeah, so the Colorado State is just basically, that's where Bill Gray, who's now passed away, kind of was the early pioneer in seasonal forecasting, and he started that in the 80s. And he just liked Colorado. It's really what it was, and he figured he could study hurricanes from anywhere. Why not there? So it's stuck there because of him, and they were the first to do it. And now Phil, guy by the name of Phil Klotzbach, who he worked with, has taken over. So we'll continue to get that. But yeah, I get that question a lot. Why in Colorado, right? And then on the other one, on the European model, well, it's been run at a higher resolution. And so you got to remember, there's different kinds of models. There's global models, there's short range, high resolution models. So when we're worried about these tropical cyclones, we do have models we run just for the tropical cyclone, but we also have these global models that are pretty good for tracking the center and things like that. So the Europeans basically put more money into their global model than we did many years ago, because we had more severe weather concerns, and we put a lot of money in short range, high resolution modeling too. So we have more modeling demands here in the United States because of severe weather. So we were kind of playing catch up with our global model over the last few years. But now the European model is really not any better than the United States model, at least for tropical cyclones. It was a few years ago. It failed miserably for Laura, the European model did. It was a big miss. And they're still studying why that happened. Because it is a pretty good model, but it's neck and neck right now with what we call the global forecast system for the U.S. But it was winning for many, many years, and they just put more money into it. It had higher resolution data. It was 9-kilometer grid instead of, say, 20-kilometer grid like ours was, for example, so higher resolution. But when we get into a tropical cyclone, we look at a bunch of different models, because any one model can miss on a storm. So whatever model's the best on one storm, it's not necessarily the best on the next. That's the tricky part of hurricane forecasting.
I'm walking over here. I have
Yeah,
a
I
quick
can probably
question.
just have you talk into this here.
Can I have your cell phone number?
Yeah. So that's a good one. Yeah. So I think Jimmy's already got it. So if you, yeah.
The question I have is, I know, like, you know, most of the time on your local station.
Oh yeah. I think we can figure that out now.
For hurricane information, and I was just wondering how does the National Weather Service collaborate with the local stations and also with those pay for weather forecasting companies to make sure the message is accurate and that that we hear what you believe we need to hear.
Okay. That's a good question. So that's a challenge. So we're better at working probably with the TV stations than we are with all the private weather firms, because there's so many people now involved in the game, like nationwide. You know, I don't even know some of the people forecasting in the private weather firms, and they do whatever they want to do. So I don't really have any influence over them. So, you know, that is what it is. Some are doing a good job, some not so much. Yes, we work really well with the media, but remember, the media is a competitive market. So sometimes there may be a little tendency for, you know, them to sort of go for it a little bit. But we work with them on that, and we have chat rooms where we talk with them and things like that. So we are definitely in constant communication. That doesn't mean you're going to get the Hurricane Center forecast from every person on TV. That's their call. A lot of them do stick to it. It's hard to beat, I can tell you that. The Hurricane Center forecast, they are experts and they do a pretty good job. So that's kind of how that works. Yeah, good question. Yeah. So what's interesting about that, so it is developing still. So if we do get impacts from the El Nino, it'll be more August, because there's a little bit of a lag there. I don't think El Nino is going to be a huge driver for the weather that we're actually getting here this summer. It's kind of looking a little above normal, but not on the temperatures, but not super. above normal. I know we have this heat wave coming here this next week, but that doesn't necessarily mean we're going to have this strong heat, all summer. Yeah, we have a bigger correlation with La Nina, the opposite for the summer. So El Nino will affect us in the fall and the winter. It has a big winter time signal here. We're probably going to get more rainfall come October, November because of the El Nino, and we'll have an increased risk of severe weather in the winter. But for the summer temperatures and rainfall, it's kind of a weak correlation. So I'm not sure it's going to affect us that much here. Mm-hmm. Sure, go ahead. Yeah.
Yeah, I wanted your cell phone number as well. But what are the most critical factors that impact hurricane track predictability?
Yeah.
Is there one or two or three, or are there just so many variables? Any one of them or several of them can really change it.
I think the big ones are, so it depends. The track forecast in particular, is going to be how solid is the steering winds at the middle and upper part of the atmosphere. How confident are we in the mid-level sort of pressure pattern that it's going to experience? And that's different for each storm. So if there's a big ridge of high pressure, and it's going to just steer right around it, we're probably going to be pretty confident. If the flow's kind of weak and there's these little disturbances in the flow that could sort of kind of nudge it one direction or the other, depending on if that disturbance gets a little stronger, then it becomes a little more uncertain. Like Ian was a lot more uncertain than, say, Laura, and it was just due to the way that mid-level flow was. So we kind of know when the models are going to have a harder time than others. The Rita, what was interesting, Rita was originally forecast to also come in around here and then made landfall in Louisiana. Not a very good forecast, but it was a really complicated flow pattern. It was around the edge of a ridge high pressure, but the high was well off to our east. And so we were kind of left in this area of, well, if this disturbance that's kind of approaching from the west and going around that ridge high pressure, if it gets a little stronger than we think, it's going to deflect it more off to the east and north. If it stays a little weaker in the model, then it's just going to come right into here. So just the strength of a little disturbance sometimes can make a difference. But like I said, modeling gets better and better and better. We also do drop sondes now all around the Gulf to help initiate when we have big forecasts. So we're not gonna see the kind of error we saw with Rita, I don't think, with a hurricane. Ian is probably as bad as it gets, where it kind of tracks on the edge of the cone. Usually the ones that track outside the cone are either kind of drifting, don't have a really good movement, or they're weak. They're kind of sheared, and the thunderstorms are off on one side, and so the center might reform. Those are the ones that we really worry about having a lot of track error. On the intensity error, sometimes if land is affecting it, like if it's going through the Caribbean, that can be a mess. Or if we're a little bit uncertain about the wind shear forecast for some reason in the model, what does it look like in 3 or 4 days, and we can have some uncertainty. But we're getting better at the intensity, but we still have some work to do. Mm-hmm. Yeah, and if he's in your neighborhood before a hurricane's coming, that's a bad sign, right?
Do we have any more questions here in the room? Nothing online? Thank you very much. This is great. This just brought back like so many bad memories of hurricanes. Okay, I think we are up to break. So we will take a 10-minute break. Thank you to Barbara Yoder, George Valdez, all y'all that brought stuff. Thank you very much.